everybody. Welcome in this LinkedIn live webinar. Today, I'm joined by Antoine Aymer and Wouter Ruigrok. I'm myself, Marselis. We're all from Sogeti, and we gonna enlighten you about how to use GenAI for quality engineering and testing. So let's take it away.
Thanks, Rick. All right, so let's go back to understand what we're trying to achieve. So we are here really focused on applying generative AI to amplify software quality engineering. And if we take a step back, SQE, our discipline, is all about reasoning and structured methodology. So we really ensure that the software that we are developing and testing and assessing really meets business needs. And we're doing it by applying logical processes to analyze, to test, and validate the quality. To make the right decisions at the right time, we are quality engineers. We rely on how we think, how we evaluate info, how we act on it. And so far, this reasoning has been driven by us, by our human intelligence. So we use intentional thinking to analyze information, to make decisions and solve problems. We rely on logic, on our experience, on the understanding of the overall context to understand, and we create meaning. Large language models, on the other hand, follows a different process. It recognizes patterns and generates content based on data, on algorithm, and obviously on probability. However, AI does not have a true understanding or a conscious intent. It only simulates reasoning. So our challenge is now, how can we combine these two approaches? How can we enhance human reasoning with GenAI generated insights to improve the accuracy, the efficiency, and the decision-making process? And unfortunately, on the next slide, we're actually talking about the J-curve effect. And it's a very known things that we are measuring and assessing as soon as a new tech comes in mind and hitting software quality engineering. So stakeholders initially are expecting improved performance, but in reality, performance drops due to misalignment, and in GenAI, it could be outputs do not meet expectations. There's context gap where models or GenAI lacks the deep domain understanding. There could be operational friction as well, and there could be quality inconsistencies where outputs vary, requiring manual review. So this temporary decline is actually, unfortunately, a natural part of GenAI adoptions before reaching success, value, and stability. And there's actually, Wouter, I think what we had is actually a very concrete example of where GenAI can actually fall short of value.
Oh, well.
Rick, can you explain this one?
Let me first quickly refer to the whole thing of test design. So what people think of with test design often starts with things like simple boundary value analysis. And here you see an example where we have two boundaries with the two boundary values. And then if you look at, and if you apply four-value boundary value analysis, that means we have four values at each boundary. So in this case, 8 test cases. And if we try this in a generic large language model, we get reasonably well results. And one model is better at it than the other model. So, well, you can probably not see all the details here, but the main thing that we wanted to convey is that even with the most intuitive test design technique, boundary value analysis, still the models already struggle somewhat if you just put in one simple plain prompt. So that's why you need more than just a simple plain prompt. And that's basically the reason why the GenAI amplifier was created.
So essentially here, we can already see that to generate first-time right content and achieve the same level of quality, there are challenges all along the way, right? And in reality, to really get to that point where we can get to that content, there's a lot of things that we have to convey. So for instance, LLM can provide and produce poor quality output because of a series of flaws all along the process of using it, where we are using poor quality input or making data overly complex or irrelevant, leading to confusion, where we are lacking context, sufficient context for the LLM, causing weak and unreliable responses, where we are giving simplistic instructions to the model, leading to lack of accuracy, lack of stability, lack of consistent output. And all models should be used for the same input and for the same use case. So we also must also adapt the choice of models depending on the specific needs. And then it can also generate a huge volume of output, creating excessive info, excessive data that in turn we have to refine. And in reality, so what the requirement here is that we should really filter high quality inputs, removing the noise and making sure that the input that we are feeding the models is of itself of high quality, which is again not always the same. We must provide a curated context for the models to make it understand a little bit more the background. We need to apply much more precise instructions, I would say prompt engineering skills, really step by step. And that's sometimes the overlooked complexity about using GenAI. It looks very simple, but to get to a point where we can generate consistent quality is actually hard. And then we need to optimize the model selections, the cost control behind it, and really aligning the right model behind the task, and different also things that we have to do on filtering the output. So this actually is I think, overlooked challenges before we can actually get to the point where we can, for SQE, generate first-time right content. So I think, Wouter, you have a good news for us, right?
I sure have. So indeed, so we heard about the challenges that we see and how to overcome that. So with the GenAI amplifier, what we did is in a fortified environment, so where we have a cloud native solution where we can put in guardrails, where we can control the data that's going through the solution, and where we have also cost control, user management. So really an enterprise ready environment. We created the GenAI amplifier. And what we did with it is we integrated over 60 use cases of commonly common activities that take place in the software development cycle. So the example that Rick explained in the beginning, for example, the boundary value analysis, that's one of these use cases. We'll come to much more. So there are a lot of use cases integrated, which is already standard out of the box. And next to that, we also have what we call the bring your own use case. So if you have additional use cases, which we don't have standard out of the box in the amplifier, then it's possible to create your own and enhance the features and the functionality in the amplifier. Key is also understanding the context, as Antoine was explaining earlier. So what we also integrated in the amplifier is a knowledge system using RAG technology. So that gives you the opportunity to add your own context, your own information to the amplifier, and that helps to make your output, the result that's been generated, even more fit to your needs and to your context. And of course, as what we are used to with all GenAI solutions at the moment, is that we can reiterate on the outcome. So if you first generate an output and it's not completely to your liking, you can reiterate on it and you can enhance the output even more where needed. So yeah, all this together gives you really a ready-to-use solution to make all the benefits from GenAI technology at the moment. So if we look at these use cases, the core use cases that we have introduced in the Amplifier are across the whole software development cycle. So we see from business demand, where we create our requirements and increase the quality of the requirements already, towards design and also test and deploy features. So for all activities in the software development cycle, there are use cases integrated to help and to amplify the people in the team. As mentioned, business demand, the requirements creation is also in the Amplifier. For today's session, we will focus mainly on the test use cases and mainly test advisory and test design. But be aware that it also helps you to really benefit from shift left. So the better the quality of your requirements is, the better the output generated with test cases will be as well. So we will not go into detail with it today, but it's also included into the use cases of the Amplifier. So let's zoom into a little bit more into the test cases that we have. Out of the box, if you ask a LLM to create test cases, then it will come up with some more or less random test cases. It will give you some valid, some invalid, some boundaries, but it's not really providing proper test cases as we would like it as from our quality engineering perspective. So what we did here is include also our TMAP knowledge and incorporated the body of knowledge from TMAP in our test design and applying these test design techniques to create a comprehensive set of valid test cases, which help you to increase your coverage and therefore also improve the confidence in the value that you're delivering with your team. But that might bring a different challenge, because there are quite a lot of techniques to apply. So then the question might raise, okay, which design technique do I need to apply, and which one do I need to use in the Amplifier? So therefore, we also introduced what we call the test advisory feature. And maybe that's a nice one to show to you in real life. So therefore, I'll looking to you, Antoine. Can you maybe share with our audience how the test advisory works?
All right, so here we are in Amplifier. As Wouter was saying, we have multiple use cases for the entire life cycle. So right now, what I will be doing is I will go on the test menu and I will open what we call Test Advisor. And the idea of Test Advisor is we can upload an input. So let me go for an input here. Okay. And the input is actually, we'll have an eye on it, a file with a business process model for an SAP system with some requirements already done. So the idea is I am asking the models to help me understand how I should approach this specific input from the recommendations from TMAP. Okay, and bear in mind that behind it, there's a whole lot of security aspects that we've taken care of. So here we are in a matter of few seconds with the underlying instructions, how we're getting. So here, for the input that I've uploaded in the system, in the Amplifier platform, I've got 3 out of the 4 coverage groups that are recommended to us, okay? And there's always an explanation here why specific groups make sense. So here, for instance, the last one that we were presenting, the appearance coverage group does not make sense because it's not relevant for the user story, okay? So what actually makes sense are the 3 different coverage group: process, conditions, and data. And inside the instructions, inside the process that we have predefined, we've actually asked the models to help us recommend what is the best technique for each coverage group. So here, for the process-based group, we have process cycle test as a design technique, the test coverage level, and yes, for these specific user stories and input, what takes precedence is this one, okay? So there's also a notion of precedence in the way we are recommending how to approach test design for this specific input, okay? So this is a very clear example, and the idea now is once we've done it, we can first challenge the output for sure and use our skills and competencies, but then try to then generate the test cases pertaining to each design technique. So I'll stop sharing here. Wouter, if you can take over again. So how did we create this test advisory feature? So first, we completely detailed and documented the way experts using coverage-based testing were approaching test design. So here we separated each step and trying to understand the relevancy of each coverage group. So we have one agent for step one that really understands the relevancy of process-driven testing. So we have here a set of instructions also available in the knowledge system of Amplifier to really help understand the models. What do we mean by process-driven testing? And as Rick was saying earlier, we do not rely on the pre-training or the training of the models because first we are testers, okay? So we really want to make sure that the models truly understand what we mean by each of these 4 steps, okay? So step one goes for process. Step two assesses the relevancy of conditions-driven testing. Step three assesses the relevancy of data-driven testing. And step four, appearance-driven testing. All these prompts run sequentially, and we store the output of each prompt in a dictionary. And we have a final agents that consolidate the results of all these agents, the first 4 steps, and then we generate an output. And you can see here, this is a more advanced way of using generative AI. Here, I'm not talking about a agentic system because there's a clear intention, there's a clear flow that we need generative AI to follow. So this is the way we've deployed Test Advisory to reveal a little bit of the secrets behind the hood.
So let me explain briefly about process cycle testing and path coverage for those who don't remember. So often a business process, but also a program flow for a piece of code may be visualized using a flow diagram. And in process cycle testing, what we normally do is make test cases to cover each and every path in the process flow, but to higher coverage levels, because multiple coverage levels are possible. And like Antoine showed in the test advisory example, there it advised a higher coverage level, and then you test all the combinations of paths that come in and go out the different decision points. And this is a simplified view where you can see all the incoming and outgoing paths and all the test situations that will ultimately be combined in test cases. And for a simple graph like this one, it's easy to create it by hand, or at least I think it's easy. But if the graph becomes larger, for example, if you use SAP flows in an ERP system, then it becomes much more complex, and then the amplifier can help. And maybe, so this is an example where you see how much time it would cost if you do this manually. And if you use the amplifier, you save a lot of time, and also you, potentially miss less, because people, they tend to sometimes miss combinations in a complex flow.
And before I actually share on the platform, we have the time that you shared here is the time done by experts. Okay, so if you're less expert on the technique, it might actually take you a little bit longer time. Okay,
That's true.
so let me share my screen again and showcase how we can actually do it in Amplifier. So we're back in the platform here, right? So we've done test strategy and test advisory. So now I will enter coverage-based testing. So the first one I've got is process cycle test here. I will actually use the same example that I had before, right? That I was sharing, which again was advised to me by Amplifier to use process cycle test. So here we are. So here, one of the first thing is I should actually further contextualize my request. Okay, I've not done it for sake of simplicity and for the demo, but it's actually the first things we have to do before sharing the input, making sure you contextualize through the rack system, through the knowledge system, what it is that I'm asking the system to do. So process cycle test, what we've done is we documented the way the human expert, and I'm insisting on the word expert, is actually deriving physical test case from an input. Okay, so you can see here on the top menu, we've got 3 steps. First, because we truly want to think that when we generate test cases, we need the expert in the loop. So this is not as the previous flow that I was showing. We are putting manual steps between each agent goes to the next one. So the thing is that we've able to do from the input that was the same here, right? As a reminder, there's no difference. The first step is to understand and assess the test situation. So we can generate a flow chart here, as a human could be doing, like decision point 1 and decision point B until it's done, okay? And in a nice table with exactly the same table that trick you were showing earlier, okay? And so this is the first thing. And to be honest, I could actually disagree with the models, depending on the model I'm choosing. So here we are putting a manual step where you can actually change whatever you want. Okay, so remove a decision point because you do not think it's a decision point, or add maybe missing one here. Okay, let's say I am agreeing with the models and the first output from the test situation step. I will then go and create the logical test cases, which are derived from the decision points and the understanding of the test situations. Okay, so we have to wait a little bit, and we have to think that it's not a deterministic system based on code, and there's API behind it that takes a bit of time to retrieve it.
Yeah, but maybe while we wait on the amplifier to come with a response, this is for me already an example. You stressed on it already before, the expert in the loop. But to be able to assess the intermediate results, to see, okay, do we have all the decision points? Do we have the right path combination? You need to understand how the technique works and to validate it. And if you know the techniques and how to apply them, it's not that much work to just validate it. It would be more work to create this result, but just validating is done more rapidly than creating all these situations yourself. So there you see still the benefit in time saving, but you need the skilled expert to judge whether the output is correct or not.
Yes, so actually it was much faster than I thought. So we have here for the input 3 test cases. Again, you can debate that, with your skills, if they are the right ones or not. But again, we try to make sure, as we were sharing, we need to generate first and right output that we can really get as close as possible. How many times we are generating the or actioning on the click button is actually hit really high quality output. Okay, so here we are now. I can still, again, as I was sharing, challenge the output and make a change, right? This is an editable box. And then the last point is really to generate physical test cases, which is enriching the logical test cases with real data. So even the data that we have can also be contextualized or from the knowledge system. So you do not allow the LLM to create its own what it thinks of relevant test data, but really the one that actually matters to you. And it's actually very relevant for ERP testing. Okay, so here we are. Today, 4 is quite fast, which is the models I'm using. But again, I can use Anthropic, I can use Mistral, I can use Gemini. It doesn't really matter. Okay, and here I've got the logical test cases, but now they're turned into physical test cases. And you can see here, well, it's for me, it's for SAP testing, so it's a little bit different here because I've not uploaded any test data. But you get the idea is that now these test cases are fully consumable and ready to be automated. Okay, so this was it. It was the first technique showing how we went from test advisory going to process-driven test cases and using process cycle test. So now, Wouter, Rick, I think we need to go to the next technique that was advised to us by the Amplifier.
Well, maybe before we go into the next technique, you can explain a little bit more on how it works in the Amplifier. Let me reshare my screen and then...
All right, true as well. So as a recap, and you actually saw it on the screen, it's a sequential flow of 3 agents here. However, because process cycle test is a little bit more complicated and requires a little bit more reasoning and manual check and expert in the loop, we've actually added this step in between. So it's kind of similar here, but there's also the input of step 1 has to be very clear done, okay? And the output of step 1 serves as input of step 2, but again, corrected or verified by the tester. And yes, on top of it, we have 2 hidden RAG files in the knowledge system. One talks about the theory of past testing of process cycle test, and another one is really showing concrete examples so the model really truly understand, again, what it is that we are sharing and meaning by process cycle test, more than relying on its own pre-training mechanism, which is, again, for users, a bit of a black box. Okay, so now let's go, I hope, Wouter, to the next one.
Yes, let's go to data. Rick, do you want to elaborate a bit on data?
So this is an example. We took a simple example of a coffee ordering system. And what people often say is test every combination. Now, even in this relatively simple system, where we have 4 types of coffee, 5 types of milk, 5 types of sweeteners, 6 types of cups, 6 types of packaging, some dates that possible. It doesn't look too complex, but if you calculate all possible combinations for all test cases, it comes up to 280,000. And then, of course, everybody understands that it is impossible to do so. On the other hand, people may say, okay, just test every value once. Well, I could do that in only 6 test cases. And then you would think, well, maybe 6 test cases is a little bit too and not enough to get real confidence in this system. So is there a possibility in between? And of course, yes, there is. There is pairwise testing. And with pairwise testing, you would only need 36 test cases. However, determining which of the 36 is quite a challenge, and manually it would be very difficult to do. It can be done, but takes an awful lot of time and a lot of skill. However, there are tools to support us in this. And the nice thing is we also made the amplifier to support us on this data combination testing test design technique.
So allow me to take over now again and start sharing my screen. So we are once back in Amplifier for the last time. And here I will go under coverage-based testing, data combination testing, and Rick, you advised me to actually use pairwise testing.
Yes.
So, well, let's actually do it. So I will use the exact same document that we use first for test advisory and process cycle test. Okay, again, no change here. Okay, it's not the coffee machine example, but it's the one that I was sharing earlier. So I've uploaded the input that is supposed to be clean and high quality in the system. And you can see here that we have split the data generation technique and pairwise testing technique into 4 different steps. So the first step is we want to extract the logic, the hierarchy of the meaning of the content of the input into parameters, into values and constraints. Okay. And this is one of the complexity here is how can we make model and how can we use the advanced generative reasoning capabilities to actually just do this. Okay, so the first thing is we can actually also verify that the generative reasoning has been done properly. So we can see here we have parameters, data, we have values here, we have constraints. Again, that were extracted from the input. And again, to make it right, it's actually not too much easy. You can actually just do it with a simplistic 5-sentence instruction. So it requires a little bit more curated work behind the hood. All right. So now the idea is that I'm asking the amplifier to verify the formatting of it. And I will explain why this actually step actually does make sense. So in a matter of a click, not even 1 second, I went from converting the parameters and the constraints into the list of logical test cases. And I can tell you, this was not done by generative AI. The first 2 steps that I was sharing were done by GenAI, but not the third step. And there's a reasons behind it I will unveil a little bit later. So now we have the absolute perfect logical test cases because this was code done behind it. And now I can actually revert back to using generative AI to convert these logical test cases into physical test cases. Okay, this is why here it takes a little bit of time because again, I'm running an API behind it. Okay, and here I've got them and we have this little column that truly makes sense for testers, expected result and actual result. And I've got all the test cases with example of data to again enrich the logical test cases. So this all makes sense, right? And now I want to unveil how this use case of putting pairwise, amplified pairwise by using generative AI was done. So Wouter, if you want to start sharing your screen again. All right, so this is yet another type of flow which differs from the other ones. So here we have 4 agents, and the first step was we must extract parameters and constraints from an input. Okay, so this was done. I had this manual check here that allows me as an expert to understand and challenge the output from agent 1. Agent 2 actually verifies the format of the output of step 1. Why? Because in step 3, we have embedded MSPICT in Amplifier. And we know that MSPICT is, let's say, almost perfect on generating logical test cases based on an input. However, the complexity sometimes for testers is how can I generate the entry file for MSPICT in the best way possible, both in terms of applying the logics behind it, parameters, constraints, and all of the things, on top of respecting the entry format of MSPICT itself, the semicolon and everything, which is, sometimes not that easy. So the first 2 steps really are about the logical and respecting the format for MSPICT. And we have now the final step 4, which is all about generating the physical test case. Here again, generative AI falls in the picture back again. So 4 different agents here, not all about generative AI, but generative AI is used whenever it makes sense. And on top of it, to write it up, we have 2 rank files again to explain a little bit more about the theory of pairwise testing and multiple concrete example to have the model truly generating high quality output.
Yeah, I think adding to that reg files there is part of the success of the output. We spend a lot of time on crafting good examples for the model to use and generate your own output. So this is now the theory, of course. We showed it in a demo, but as the British say, the proof of the pudding is in the eating. So let's see how it works in reality. So we got a lot of feedback using it in real life, and well, let's start with some key observations that we have seen, and maybe Antoine, you can kick it off.
So as I think we try to share throughout this presentation, first, it's not just about using generative AI for the sake of using it. It's how we can truly convert and amplify our work. But again, the first mandate for us is looking at us in a mirror. Generative AI will only amplify the good work that we're doing. Otherwise, it's back to garbage in, garbage out. And obviously, throughout the use of generative AI, we must be skilled enough to challenge the output. Do not trust the output, because we understand how the system behind the wood is actually getting developed and created. So we need, the very first things we need is, do we have the right practice expertise to use generative AI? And this is the very first thing. There's a clear mandate for expert in the loop. The second one is, as we showed earlier, what truly matters to get a first-time right output, it's also to have high-quality input. And from a testing perspective, we are inheriting a lot of things from others, from product owner, from business analyst. And the need for quality, the mandate for quality also start really early. So shifting left qualities of quality of document, input, structure, acceptance, user acceptance criteria, scenarios embedded into the user stories is critical to generate high quality test cases. And the thing is, if we do a great job at test design based on high quality input, there's going to be also tremendous impact on automation testing. The third one is, obviously, productivity gains highly depends on the context. So we need to find ways of tuning the RAG system, the knowledge system. And again, this is not a science, it's a fine art. The number of files, the type of contents, the length of content we put on the RAG also has an impact on the output. And again, there's a new things behind generative AI. We've done a lot of experiments with, a large amount of our clients. There's also a way of getting acquainted and used to using generative AI. We've seen some experiment really achieving, let's say, 5 to 10% sort of low productivity gains as we start. And as testers and users and engineers, again, that understand how GenAI works, whether it's Amplifier or agent or agentic system, the productivity gains over time increases by a significant portion. So there's also a way of not just understanding how the system works, but how we can get productivity gain by using it alongside the various sprints. So the fourth one is, as we get acquainted to use cases, there's more demands. People truly understand the power of generative AI and truly wants to get more. And the last point is obviously the tight integrations with the broader ecosystem, bi-directional flow with Azure DevOps and Jira and other test management system. The only thing is, let's be cautious about this automated bi-directional workflow, because we might have a tendency of automatically pushing stuff from generative AI to our test management system without verifying it. And again, this must not be done. We must have this expert in the loop to verify that whatever we feed our system with is of high quality. And Wouter, now let's talk a little bit about the figures, and not just talk about observations.
Exactly. So you are already telling about it. if you use the whole flow and start from the input already, improving the quality of the requirements, then you benefit most of all the value that GenAI can leverage. And that's also what we see now in reality. So there are multiple clients of Sogeti where we are using this Sogeti Amplifier now, and we see some really good results in saving, if we look purely from a time perspective. There are also some other benefits coming from it, but if we just purely look at how much time are we saving, then you already see some really good results there. So what you see here are real numbers from different types of companies, different also around the globe. You see the flags in the top, so they're from different countries. The results of using the amplifier in real life. And what we really see is that if we start already by improving the quality of the requirements, using the amplifier to increase the quality of the acceptance criteria and the clearness of how the requirements are formulated, then that cascades forward to the creating the test cases and also automating it, even to automate scripts. So then you really get the biggest value from using generative AI. What you also see in this slide is that it is not completely replacing manual effort. Now you still see also in the columns about GenAI Amplifier, there you see still the time needed to prepare the input. Antoine was referring it also during the demo that he just used our plain document and didn't optimize it yet. But in reality, that is what you would do. And then you remove redundant information or not necessary information. So there's some pre-processing needed to put it into the amplifier. And even also if the output is generated, then you still will do some modifications there manually as well. But still, if you compare that to doing everything manually, then you see that there's a lot of time saved in these activities, which frees up, of course, capacity in the team, and that we can focus on the difficult task where we need our human reasoning maximized actually. So these are our time saving. Other things that we also notice when we use it in real day-to-day practice is that the biggest value is when we use it in more complex situations. So the complexer the context, complexer the user stories that we are working with, the more we are saving in times of time saving, but also it increases the coverage level and therefore the confidence that we have with the testing. So using these techniques and applying them, that helps us also to add useful coverage and increase therefore the confidence in the products that we are developing. So I think with this, we are reaching the end of today's webinar. I hope you find it insightful. We're still here to answer any questions, so feel free to ask them in the comment section. Then we can respond to it. And if you want to know more about Sogeti, what we do, and also about the Sogeti Amplifier, please visit the website that we share now on the screen. Be aware we don't sell Amplifier as a product under license, so it's part of our services. That's how we use Amplifier within Sogeti. And thanks all for attending this webinar, and I hope to see you in a future webinar as well. Bye bye.
Bye bye.